this session and the one after lunch are going to be around clustering, and it's always a popular topic when sort of presenting to a Tomcat audience. And I found this out when, I think it was ApacheCon Budapest, the first one. I submitted a training course on clustering. Thought, yeah, I'll get there a few days earlier, teach a training course, catch up with a few people in the evenings. But it was kind of, well, yeah, I'll give it a go. Wasn't massively enthusiastic about it. And as the conference got closer, there was lots of interesting stuff going on in Tomcat. And actually, I didn't really want to teach the training course. And I'd much rather just spend my time in the hackathon instead. So I thought I'll just contact the organisers and just see whether I've actually managed to sell any tickets for this course that I had done absolutely no advertising for whatsoever. The only place it was advertised was on the registration screen. So I just politely inquire, as you know, so I was expecting to say one or two. Oh no, 16 people have signed up. You're definitely doing it, aren't you? Yeah, I guess I am now. So that's sort of where this material started. But it does seem to be a topic that a lot of people are interested in, hence why we've dedicated 2 slots to it today. And I'm going to tackle it in 3 chunks. I'm expecting to get somewhere towards the beginning of load balancing by lunchtime, but we shall see how things go. So we're going to start with looking at reverse proxies, then extend that to include load balancing, and then extend it further to look at clustering. So basically sort of building it up in layers as we go. So let's start with reverse proxies. Easiest probably to understand with an example. If you look at Apache's web properties, our Bugzilla bug trackers are all hosted on bz.apache.org, and as far as you as a user are concerned, you just go to bz.apache.org and they're all there. You have no idea that there are multiple Bugzilla instances behind that could be on completely separate machines. Actually, they're not. They're all on the same machine as this one, but they could be on separate machines, and that would be transparent to you. And that's essentially what the reverse proxy is doing. It presents multiple services as if they're coming from one host. Now, you might use this in an enterprise because you've got a favoured platform. You like to run all of your servers on one platform, but you've got this one annoying product that somebody important insists that you run, and it only runs on a platform you don't like. So you have to run it on that platform, so you put it on a different box and then you proxy it through one of your existing servers. It might be that you've got 4 or 5 different apps that all have wildly different requirements, but they all support HR. So you put them all on their own separate boxes, but you present them all through hr.yourorg.internal or whatever. But essentially a reverse proxy is a way of pulling together multiple different services that might be on different boxes, could even be on different continents. You'd have to worry about latency, but they could be disparate, and you can present them through a single web host. Most often when we see this happening, it's either for instances like this where you want separate instances because they're easier to manage, or it's because you've got things that are using different technologies. So you might have a couple of Java web apps, something that's Python based and something else that's, pick a framework of choice. So it brings those together, like I say, through this single interface. And as far as the user is concerned, they're interacting with this. What happens from this point onwards, they don't know about, and frankly, they don't really care about, as long as this bit works. So I think we've covered all of this. Looks like a single host. It's usually multiple, doesn't have to be. And another reason for using it is you can actually use it to add features. Now I'll take a Tomcat example that doesn't actually apply anymore because we've added the feature to Tomcat. But if you go back before Tomcat supported Windows authentication, if you wanted a Tomcat app and you wanted to add Windows authentication to it, one of the easiest ways of doing it was, well, let's just reverse proxy it from HTTPD, because HTTPD supports Windows authentication. So we get HTTPD to do the authentication, pass the authenticated ID to Tomcat, and then the app has got access to the ID, and bingo, you've added that authentication to Tomcat without actually having to change anything on the app. So you can use it for that sort of thing as well. So what we're going to look at, we're going to look at the choices you have for the protocol to use between your reverse proxy and your backend Tomcat. I'm going to talk primarily about HTTPD acting as the reverse proxy. Other reverse proxies are available. And then we're going to look at the Tomcat side of things and what your implementation choices are. And then I'm going to talk about troubleshooting and some of the things that can go wrong. typical things that can go wrong and how you can approach fixing them. In terms of questions, as before, I'm happy to take questions as we go along. Please do wave your hand, get my attention, and we'll deal with it as we go. So when Tomcat's the back end, you've got two protocols to choose from in terms of how you proxy, AJP and HTTP. And HTTP2 is potentially an option that's fairly new. Does HTTPD proxy HTTP2 yet?
Yes.
It does, okay. Haven't seen really any user requests for that yet, but I imagine they'll be coming along. And essentially, everything I say about HTTP broadly applies to HTTP2 unless I'm talking about connection level characteristics. Certainly in terms of functionality and things you'd need to do, the two would be the same. Now, in terms of whether you want to use AJP or HTTP, there isn't a clear, you should always use this one. It does depend on the circumstances. Both support persistent connections, although on fast LANs or on the same machine, that doesn't make a huge amount of difference. So really, it's down to what you're actually trying to use it for will probably determine which protocol you actually want. So if we look at AJP first, it's often referred to as a binary protocol. Well-ish, sort of, no, not really. What happens in AJP is common headers and common values are encoded. But if it's uncommon, it's in plain text, and all of the request body and all of the response body are all passed as is, effectively in clear text. So it's not really a binary protocol in terms of it's not compressed, it's not encoded really, it's pretty much clear text. It's slightly harder to read if you're looking at it in Wireshark than HTTP, but to be honest, if you've been looking at AJP for half an hour or so, you can read it pretty easily. So it's not really binary, although some people do mistakenly refer to it that way. One limitation that it does have is that all of the request headers must fit in a single AJP packet. Now, a default packet is 8K and the maximum packet size is 64K. So you'd think, how on earth could you fill up that much just with request headers? You'd be surprised. First of all, cookies. Some apps really like very, very large cookies, and they can certainly get you over the 8K. The other way you can do it is if you're terminating the TLS connection on HTTPD, HTTPD will pass the TLS information to Tomcat, including the user's certificate. If that user's certificate is at the end of a very long chain of certificates, that's quite a lot of data, and that can chew up a lot of that 64K very quickly. So normally, no, 8K is fine, but there are cases where you need to increase it. One thing you do need to be very careful of is you must make sure they're set to the same size on both ends. Otherwise, things are going to go wrong. And there is no safe, oh, it's okay if that one's larger than the other. They have to be identical. Because if HTTPD is sending larger packets than Tomcat expects, Tomcat won't be able to read request bodies. If Tomcat is sending larger packets than HTTPD expects, HTTPD won't be able to read response bodies. So basically, if they're not identical, it is going to fall over. Unless, by some miracle, everything stays below the limits that they're both expecting. Doesn't happen that way. So I mentioned passing TLS information. This is something that AJP does for you automatically. So if HTTPD terminates TLS, then the important information, the fact that TLS has been used, the client certificate, the cipher, all of that data gets encoded in the AJP headers and gets passed to Tomcat. And on the Tomcat side, that is then injected into Tomcat's internal structures. So as far as Tomcat is concerned, it looks like the TLS has been terminated in Tomcat, and Tomcat will behave exactly the same way as if it has been. What it doesn't support is encryption of the communication channel. And if you're in an environment, certainly a lot of banks are in this situation, that says any traffic that contains user data anywhere, even if it's between processes on the same machine, must be encrypted, then AJP might not be the protocol for you. And there are ways to do it. IPsec, VPNs, SSH tunnels. Generally, if I need to encrypt it, I don't like setting up any of those, so I tend to choose HTTP, which I'll talk about in a minute, but there are ways of doing it with AJP if you need to. Something else that AJP has is the ability to use a protocol level ping to validate a connection. When you've got front-end reverse proxies, back-end servers, network connections between the two, there's always the possibility that something's going to die. It's very helpful for the front-end server to know that the back-end server is still alive before it sends the request. So because it's much better, rather than send the request, wait for the response, wait for the response, wait for the response, oh, it's timed out, maybe the server's failed 10 seconds later. Much better to send a quick protocol ping. You get an answer back straight away. If you don't get it back almost instantly, you know there's a problem and you can go and pick a different back-end server, because the protocol pings are responded to very, very quickly. It is literally a 4 or 5 byte packet and it gets a similar length back, very, very quick. So if it takes more than sort of a few milliseconds, then there's probably some sort of problem. So if you compare that to HTTP, which is your other choice, again, it's clear text. It's probably easier for your average system administrator to read just because they spend more time looking at raw HTTP traffic than they do raw AJP traffic. You don't have the limitations on request header size. So the headers can be as big as the Tomcat will allow. For denial of service protection, Tomcat has got limits on the HTTP headers, both in terms of the number of them and the size of the data. So just be aware of that if you have got particularly big headers, you might need to increase the sizes. But theoretically, you can go as big as you like. There's also no dedicated ping. So there isn't a protocol level way of it, is it alive? If you need to do a ping on an HTTP connection, you have to do it. You have to do a real HTTP request. And that comes with a lot more overhead than the AJP level ping does. Not a huge amount in the grand scheme of things, but it's still significantly more. The other thing that HTTP doesn't do is it doesn't automatically support the passing of the TLS termination information. So if your reverse proxy is terminating TLS and you're using HTTP, then to tell Tomcat what's going on, you have to manually add that TLS information to the proxy request. And you can do that in HTTPD by setting custom headers. Something to make sure, if you're doing that, you are effectively inputting security information into those headers. Make sure you are not passing any header with the same name that the client has provided you to Tomcat, otherwise Tomcat will treat it as trusted and secure as if it's come from HTTPD. So anytime your reverse proxy is putting any information into the headers, always make sure you overwrite rather than add to anything that's already there. Otherwise, you've got basically an injection vulnerability when Tomcat processes it. So HTTP can add it, and Tomcat provides something called the SSL valve, which does the same thing as the AJP protocol does. It takes the information out of the headers, it inserts it into Tomcat's internal structures and makes it look as if the TLS was terminated in Tomcat. The big advantage that HTTP has is you can just switch to HTTPS and get encryption. So if you are in an environment where you need encryption between the two, it's a lot simpler if you're on using HTTP. Just switch the proxy into proxy to HTTPS and make sure you've got the connector configured on Tomcat. Okay, you've still got to set up HTTPS on Tomcat, but that's a simple thing to do. But then again, I would say that because I set it up all the time. If you're ever having problems setting up TLS, we've got some webinars up on the Tomcat YouTube channel that literally go through a step-by-step. These are the commands you need to type to set up a working TLS environment. Now I say they were working when we did the webinar. Browser requirements for TLS do move on all the time. It's possible that the browsers won't connect to that configuration anymore, but I think we're okay. If you do find that, let us know and we'll update it. But setting up TLS YouTube webinar, do check it out. So, talked a little bit about AJP, talked about HTTP. Which one do I recommend? Well, if you're terminating TLS and you need that information in Tomcat, then I'd say use AJP. It does it automatically. You don't have to worry about setting up the headers. Nice and simple, proxy over AJP. If you need to encrypt the channel, then use HTTP because encryption is easy. You just switch to HTTPS. If you need both, this is probably more personal preference, but I would go for HTTP. That's because personally, in all the situations I've needed to do this, it's been easier to pass the TLS information than it has been to set up an encrypted channel for AJP. That might be different in your environment. It does depend on how your environment's set up, particularly your network. If it's dead easy for you to set up encrypted comms between nodes, then AJP might still be a better option for you. If you've got a free choice, then there really isn't one better than the other. Pick the one that you're familiar with, pick the one that you're most comfortable with. There is no good reason to change for the sake of changing. Just go with what you know. Unless you like a challenge and you want to try something new. Question at the back there.
If in this case you have you have AJP connections and for whatever reason, security reasons, you need to have data encryption.
Uh-huh.
Then I guess you have to go through the pain of switching everything to HTTP.
Potentially, yes. You can. So I'm going to repeat the question just for the benefit of the recording. So if you're currently using AJP and you need to add encryption, do you have to go through the pain of switching to HTTP? Yes, but. And the but is depending on how you've actually configured the proxying in HTTPD, that might be as simple as deleting 3 characters and typing 4 and possibly changing a port number. It can be very simple, depending on how you configure HTTPD, it can be very simple to switch between the two. It does depend what choice you make for HTTPD. I'll talk about that a bit more when I talk about the proxying options in HTTPD. But there are, equally, you might have set HTTPD up, so yeah, it is actually a bit of a pain. It depends on where you start from. But ultimately, that's a choice you're going to have to make. Is it more hassle to figure out how to encrypt the AJP channel, or is it more hassle to figure out how to get HTTPS working? And again, pick the one that you think is going to be the minimum amount of hassle. Or alternatively, pick 2 people to report to you, get one to do one to do the other, and the first one that finishes wins. Different ways of doing it. So that brings us neatly onto HTTPD module selection. So the internet is a wonderful thing. Search engines are wonderful things, and if you search for HTTPD reverse proxying in Tomcat, you will come up with a wealth of material. Unfortunately, some of it is quite old. Unfortunately also, some of it is not obviously old and out of date. So you will find references to mod JK2, mod JServe, mod web app. If you see anything involved with this, do not touch it with a barge pole. Run away, find something else. Those are all very, very old, no longer supported. I mean, mod web app and mod JServe are so old that they weren't even in use when I started on Tomcat. JK2 started and finished again in the early days of my involvement. So they are very, very old, but you will still find lots of sites out there referring to them. So please don't use them. Generally, don't consider anything unless I explicitly talk about it. Now, it's possible that in the next couple of months, some brand new thing might come up. It is actually the latest, greatest thing, and it does make sense to use it. It would be worth checking with the Tomcat community, probably via the users list. Thinking of using this, does it make sense? And somebody will either say, yep, sounds great, or actually, no, that's this awful project from 15 years ago that is no longer maintained. You really don't want to touch it with a barge pole. So if it's not mod JK and it's not mod proxy, check. Make sure you're doing something sensible. Mod rewrite is also an option, but generally you use it with one of the others. But so I'll talk about mod rewrite first. Mod rewrite is one of those wonderful tools that can do just about anything you want to. At an Apache Con a few years ago, there was a presentation that basically involved going through a standard HTTPD configuration and removing every single directive and replacing it with a mod rewrite directive. And you can do it. Doesn't mean that you should. Just because mod rewrite can do it, it is not necessarily the best way of doing things. There are times when it's made sense to use it. Normally, the more complex your load balancing rules become, then the more some of the things you can do with mod rewrite around doing things conditionally and expressing logic, sometimes quite complex logic, is a lot easier to do. If you do go down that route, something that's worth thinking about is you can get mod rewrite to do all those complex rules and then do the proxying for you. It effectively delegates to mod proxy to do it. You can also get mod rewrite just to set an environment variable and then use that environment variable in your proxy rules later. That might give you better separation. It's something to think about. Right, talk about that. So let's look at the main two, which are mod JK and mod proxy. So mod JK, it only supports AJP. It's developed by the Tomcat committers. Now, back when it was under active development, I always used to say, if you want to use AJP, use mod JK, because the features always land, features and bug fixes always land there first. So it's more up to date than mod proxy, which is available in HTTPD. That's really no longer the case. Anything that's in mod JK that could usefully be in mod proxy has been ported across. So these days it's much more which one are you familiar with. AJP, because it was developed by a bunch of Java developers primarily, it doesn't use its configuration doesn't look anything like your standard HTTPD configuration. It's got a few directives, and then it points to a couple of external files that look suspiciously like Java property files. That's where most of the real work happens. You can do it in HTTPD, but not in a form that will really look like HTTP configuration. And we do provide binaries, but only for Windows. Historically, we've provided them for other platforms, but there hasn't been much demand. If you're on Linux, most Linux admins are perfectly capable of building it themselves anyway. Windows is a bit more difficult, and also wasn't particularly well documented historically, so we do it for you. These days, actually, the full build process for mod JK, from a clean Windows install, this is all the stuff you need to download, these are the commands you need to run, literally you can copy and paste it. That's all available for mod JK now as well, and Tomcat native. So if you want to build it yourself, you can. But because most Windows folks aren't familiar with doing that, then we do still provide it. One of the things it doesn't do, and actually this lack of feature I think is a strength, is it won't easily let you rewrite the URL. So for example, if you've got mypublicwebsite.com/foo, what it won't let you do is redirect to mybackendserver.internal/bar. So it won't let you change the foo bit to bar very easily. It makes that actually quite hard to do. And there are good reasons why I think that's a good thing, but I will come on to that in a bit. Do make sure you're using the latest documentation. Again, mod JK has been around for quite a while, so we do suffer from the old problem of there's lots of tutorials and how-tos and references that are for versions that are 10, 15 years out of date. So make sure you get the latest docs from the Tomcat website. And just to mention that mod JK does come with a status worker that you can use for both monitoring and management. So you can, for example, look at, okay, this HTTPD instance, it's talking to these 4 backends. Okay, I want to disable that backend. I want to add, you can add balances. Can you add balances or not? Certainly disable them. No, I can't. You can certainly disable them and turn them back on. Need to check whether it supports adding them or not. Mod proxy, on the other hand, that's part of standard HTTPD. And if you look back at the history, there was, it was a while back now, there was a big discussion about, well, how do we get some of the features that we've got in mod JK into HTTPD? And there was quite a long debate that went back and forth. But what we ended up with was what I think is a brilliant solution. And that was, we'll add a new module to mod proxy called mod proxy AJP that will handle the AJP protocol. And then we'll take all of the load balancing stuff and put that in a module called mod proxy balancer. And then we've added load balancing across any of the supported protocols, and we've added AJP to the supported protocols. And it actually worked out really well. And that's how the mod JK features translated across to mod proxy. So because it's a standard HTTP module, you download HTTPD for the distro for your favorite distribution, and it's just there. You might have to enable it. It might be enabled by default. It uses standard HTTPD style configuration, so if you're somebody who works with HTTPD a lot, it'll all look very familiar. The good or bad news, depending on your point of view, is it does support URL rewriting. So if you've got my frontend server /foo, it will quite happily write it to my backend server /bar. which again is good or bad depending on your point of view, and I am firmly in that that's a bad thing to do camp, and I will go on about that at length in a little bit. Because it's HTTPD, it's available wherever HTTP binaries are available, so there are lots of platforms where you can download that. So any platform where you can download HTTPD, then you've got mod proxy. You don't have to worry about compiling it separately like you often do with mod JK. When you're looking at the two, again, looking back historically, it used to be the case that mod JK could do more complex mappings than mod proxy could. That's really changed now. You've got mod proxy, proxy pass match is a directive, which is basically regular expression matching for how you want to map stuff from front end to the back end. So you've got a huge amount of power with that, and huge opportunity to shoot yourself in the foot as well. But in terms of what you can do complexity-wise, that's really no longer a differentiating factor. If you're not on Windows and you don't want to have to compile the module, then I'd use mod proxy. If you're already using one, there's not really a good reason to change. It's a bit like AJP and HTTP. If there's not a good driver to change, I wouldn't say if you're happy with mod proxy, no need to change to mod JK. If you're happy with mod JK, no need to change to mod proxy. Again, given a completely free choice, I would lean towards mod proxy simply because in the environments that I tend to work with, I'm talking to people who are much more familiar with HTTPD than they are with Tomcat. So giving them a proxy configuration that's in a style that they're familiar with and they understand makes more sense. Personally, I've just used mod proxy a bit more, so that's one I tend to use. And again, because I don't have to bother compiling it, it's just there when I run up my Linux VMs to do the testing. But it's personal choice. There isn't I really wouldn't want you to go away with the idea that, oh yeah, I should definitely use that because Mark said so. So on the Tomcat side then, we have a choice of connectors. Now, the choice of connector and the choice of protocol are separate because Tomcat has got, for every protocol, each connector implementation has an implementation of that protocol. So if you look at Tomcat 7, Tomcat 7 supports AJP or HTTP, and it will do that with the BIO connector, the NIO connector, or the AJP native connector. Slightly different when you get to Tomcat 8. There you've got BIO, NIO, NIO2, and AJP native. But again, all those four connectors support both AJP and HTTP. From 8.5 onwards, we drop BIO. So we've got NIO, NIO2, APR native, get that right, and again they both support HTTP and AJP. Now I'll talk about Tomcat 7 and BIO because there are still a lot of Tomcat 7 installations out there. There are still a lot of Tomcat 6 installations out there. You may or may not be surprised, but we had a question on the users list not that long ago, so I think it was in the last month, somebody running Tomcat 4. And please, would we help them? Well, yes, upgrade now. And they're on a weird platform as well, weren't they? Was it AS400 or something, I think?
Oh, yeah, that's possible.
Yeah, it was Tomcat 4 on AS400, which was pretty unusual. But so yeah, I talk about these things because there are still people using these older versions. And Tomcat 7 is going to be supported for a good 3 years, I should think, at least. So this will apply. So the BIO connector, it's the default in Tomcat 7. It has been removed in 8.5 onwards, but it's blocking. And the fundamental thing about that is it's one thread per connection. And that's important to remember because that will lead us on to one of the things that can go badly wrong in a little bit. For NIO, it's the default from Tomcat 8 onwards. It's non-blocking, and it's non-blocking basically wherever it can be. So between requests, while reading the HTTP headers and doing TLS handshakes, it's non-blocking. Once you're into processing the servlet response, request and response, basically the servlet API says that you have to block, so it has to block. Unless you switch to the async API and non-blocking, in which case it goes back to non-blocking. NIO2, that's in 8 as well. That's non-blocking in the same places that NIO is. APR native, that's the GNI library that we've been talking about that's built on top of APR and OpenSSL. That doesn't block for the TLS, sorry, that's non-blocking for the next request in the headers. It's blocking for the TLS handshake. And the headers non-blocking was added from 8.5. So you can see that things do change slightly between releases, but all of this, the detail is broken down in the connectors documentation for each release. So if you ever need to check exactly what they do, there's a nice little table at the bottom of the HTTP 1.1 config that basically lists the connectors and the features and tells you what's blocking and what isn't. So they all block during read and write for the bodies. Now for TLS, BIO, NIO and NIO2 can use GSE. As Remy was talking about, from 8.5 onwards, NIO and NIO2 can use OpenSSL. APR native will always use OpenSSL. Even if you use the GSSE style configuration, it will use the OpenSSL to do the encryption. And the big lesson from all of that is OpenSSL is significantly faster. Less important, well, doesn't apply to AJP, but it does apply to HTTP, send file support. And the idea here is if you've got a static file on disk that you need to send out to the client, you could read it off the disk, process it, do a bunch of stuff, write it out to the network. But fundamentally, you're moving bytes from A to B. So what send file does is it provides a way of copying as quickly as possible. Right, take those bytes from that point on the disk, get them to that network connection, and do it by involving as little of the computer's hardware as you possibly can, please. So you get faster handling of static resources. Commit, which won't apply to reverse proxying, but that's been removed in 8.5 anyway. That's another one of those things that if you're using in 8 isn't going to be there in 8.5. Pretty much everybody's migrated to WebSocket. If you haven't already, that's what you need to be thinking of. And WebSocket support, they all support it. It is worth keeping in mind that HTTPD's WebSocket proxying doesn't behave the same way that Tomcat's WebSocket behaves, because there's sort of a difference in approaches. The HTTPD approach is everything under this URL space will be WebSocket, nothing else. The Java WebSocket API's approach is, well, we'll receive a request and we'll look at the request, and if it asks to be upgraded to WebSocket and we've got a matching WebSocket configured, then we'll send it to WebSocket. If not, we'll just let the normal servlet mapping process handle it. So in the Java WebSocket API, the URL space for WebSockets and servlets can quite happily overlap. HTTP just doesn't let that happen. It's either a WebSocket request or a non-WebSocket request. So if your app's using WebSockets and you want to reverse proxy it through HTTPD, you have to make sure that the URL space for the WebSockets is completely separate. So stick it under /WebSocket or /WS and don't have any other content under there, for example, and then you'll be able to use HTTPD's reverse proxy. Because the way it works is the client creates a WebSocket connection to HTTPD, HTTPD then creates a separate WebSocket connection to the backend server, and it basically passes the messages back and forth. What would have been nicer would have been, and it would be nice to have, let's write an enhancement to do this list, and it's been there for a while, is if HTTPD's reverse proxying would seamlessly support HTTP upgrade, which would effectively mean doing something like an HTTP connect, where HTTP just sits in the middle passing the bytes back and forth and lets the backend server handle the protocol. But that's not available at the minute.
If you use the WebSocket tunnel, it just do the tunneling by default, and then you can tunnel the HTTP connection. But it's a weird construction.
Yeah, the Tomcat on the back end because the servlets they overlap with the WebSocket space. It gets very messy very quickly. It's certainly easier to separate it out. So which Tomcat connector should I use at the back end of my reverse proxy? Well, if you're using TLS, pick something that can use OpenSSL. You'll get a noticeable performance, unless you've got so little traffic or so much compute power that you don't really notice. But generally, I would say go with OpenSSL. If you want stability, of all of the connectors, I would say NIO has the ever so slight edge. It's got the edge over NIO because it's got the edge over NIO2 because NIO is a little bit newer, a little bit older. It's been around for longer, so we've ironed out a few more of the bugs, but there's not that much in it. APR native, again, there's not that much in it, but there is always that slight risk if APR native goes wrong, it'll crash the JVM. So I tend to, as a starting point, start with NIO with OpenSSL. That assumes you're on Tomcat 8.5 or later, and go from there. Obviously, if you're using AJP, then OpenSSL isn't an issue because you can't encrypt the traffic. So those are your options. What can go wrong? Thread exhaustion is the first one. And to understand what's going on here, you need to understand the threading models in HTTPD. So if we look at a couple of examples, if you're using the pre-fork NPM, there's one thread per process, and you can set the maximum number of processes. So the maximum number of HTTPD threads is basically whatever you've set your max request workers to. There will be no more HTTPD threads than that. If you're using the worker NPM, the number of processes is set by the server limit, but each process can have multiple threads, so you need to multiply the two together, and your maximum number of threads is server limit times threads per child. Now this is important because when you've got persistent connections and blocking I/O, one thread equates to a current request. And what will happen, and this is all by default, and it's primarily with AJP rather than HTTP because HTTP will time out. By default, each HTTP thread will maintain its own connection for it to use to talk to Tomcat. And it'll start off with there being no connections, and HTTP will process requests, and over time each of those request threads will come across a request that needs to be proxied, and at that point it will open up a connection to the backend Tomcat, use it, and then leave the connection open for when it needs it next time. So what you end up with is a lot of mostly idle connections to your backend Tomcat server. Ultimately, leave it long enough, say you've got 2 HTTPD instances, each with a maximum of 400 threads. Once each of those threads has processed a request that needs to talk to Tomcat, each of those threads will have created a connection to your backend Tomcat server, and bingo, you've now got 800 connections to your Tomcat server. Now that's not beyond the realms of what Tomcat can handle quite comfortably, but say you're quite a big website that's got 20 front-end HTTPDs, each with 1,000 threads, but a very small percentage of those requests are handled by Tomcat, so you've just got 2 Tomcat servers. Thing is, eventually you're going to have 20 servers times 1,000 threads, which is 20,000 connections trying to be made to those Tomcat servers. And the chances are Tomcat will be configured for far less connections than 20,000. And that's essentially the thread exhaustion problem. They'll have very low utilization, but because it happens when you're using BIO on the Tomcat side, so it happens by default on Tomcat 7. Because BIO requires a thread per connection, if you've got 20,000 incoming connections, BIO needs 20,000 threads to handle it, and what usually happens is that Tomcat runs out of threads, but it looks almost idle. And we had exactly this problem with the ASF Jira instance. The Tomcat wasn't doing very much, but we're just getting 503 errors all over the place. Once we dug into it, the fix was pretty simple. I would say it was a 30-second fix, but it was a 30-second fix to edit the file and then about 10 minutes waiting for Jira to restart. But if it was a simple fix, just increase the number of threads. The other option is just switch to the non-blocking connector, the NIO-based connector, because the NIO connector only uses a thread when it's actually got a request to process. All of the connections, that's all maintained by one polar thread. Well, possibly 2 polar threads if you've configured multiple, but essentially one polar thread. And it maintains all of those connections. And it only passes it to a request processing thread when there's actually a request on that connection that needs processing. So in that way, you can quite happily have 20,000 connections, 1% of which are active, handled by a Tomcat instance that's configured with 400 threads. Very comfortable. So switching to NIO is another easy way to avoid the thread exhaustion problem. Other ways, just don't use persistent connections. Get HTTPD to close the connection as soon as it's finished with it. Now, this is something that can spark a lot of debate as to whether that's a hideous performance problem or whether it makes no difference at all. And in reality, it will depend on your environment. Normally, it won't make much difference. If your back-end server and your reverse proxy are either on the same box or they're on a fast LAN, then the overhead of establishing a connection is probably not that great. It's not that different from just a quick protocol ping. If you've got more latency involved, then there might be more of a problem. But basically test it in your environment and see how it behaves. Just disabling persistent might be a help. Yes, Nick?
How does SSL factor into that?
How does SSL factor into that? If you're using, so if you're doing this over HTTP, then obviously the advantage of a persistent connection with SSL is you don't have to do the handshake. Now, Tomcat will support the abbreviated handshake if you use session resumption, so that's one option. But if you're doing this over TLS, that would be a reason to carry on using persistent connections because you don't have the initial overhead. In which case, you'd want to look at one of the other options like using NIO. I have seen people try and configure this with timeouts. If you go this route, you need to be very careful. And the idea is that you get HTTPD to time out the idle connections. The problem we sometimes see is that Tomcat doesn't see that the connection is closed, so you need to get Tomcat to time them out as well. But you do need to make sure that HTTPD always times them out before Tomcat does, because otherwise sometimes those closures aren't seen by the other end of the connection, then it tries to use it and it all gets fairly messy. Generally, I'm not a fan of that particular solution. It feels a little bit fragile whenever I've seen it used. Another option is if you've got a large number of front ends and a large number of back ends, rather than letting any front end talk to any back end, you can use groups to basically say, right, this selection of front end servers talk to these back end servers by default, and only if every single server in that group is unavailable are you allowed to try a different group. And basically you can give it priority groups, and by that way, because every front end server isn't allowed to talk to every back end server at the same time, then you can minimize the number of threads that the Tomcat needs to maintain. But generally, if I had to pick a solution, I'd just turn on NIO. That was less of an option in the past when NIO was newer and less stable, but these days, particularly given that it's been the default for Tomcat 8 and we've ironed out a few bugs via doing that, I just turn on NIO and that makes these problems just disappear. Right, the next problem. In reverse proxying, by far the easiest way to create yourself a whole pile of pain, a whole bunch of problems that don't quite make sense, and things that are an absolute nightmare to track down, is to change the context path in the reverse proxy. So here we've said anything that this server receives to /foo, I'm going to proxy across to my backend server at /bar. At this point, just whenever I see a configuration like this, I feel the urge to shout, no, don't do it, please change it. By far the simplest way to avoid the hassle is just make sure that the two match, and normally that means just changing the back end. Now, it should be possible that any Java EE web app should not have a hard-coded dependency on its context path. If it has, then you might not be able to avoid this, and that would probably be the time to go and have a quiet word with the developers in a dark room, possibly with a baseball bat, because it's just that's the sort of thing that, okay, you might not be able to fix it now, but it needs to be on the backlog to get fixed pretty quickly, because as soon as you can change that path freely, it avoids all sorts of the problems that we're about to talk about. So fundamentally, don't change the context path. So why might you think, or why might you need to do that? Well, for example, marketing wants to set up a new site at, say, buzzword.com, and the app's currently deployed at some context path, say /app, and basically they just want to drop the app. They don't want the app on the end, they just want to see the root. Well, the simple solution is we'll just stick a simple root application there that does a redirect from the root app to app. The downside is that app phrase, whatever it might be, is going to become visible to the users. If you don't want that, then just deploy your application as root, and this is back to not having a hard-coded context path. Now, often the argument we see against this is, but if I deploy it as root, I don't have the app name or the version information or the whatever it is that's in the file name that I need that makes my life a lot easier. And the answer to that is we have a trick. And the trick is to use the parallel deployment naming convention. If you put 2 hashes after root, anything you put after that is just a version label, which Tomcat will note, but if you've only got one thing that starts with root, it effectively gets ignored. But that way you've got a file name that's got the label that you want, but it's deployed at the root of the root web app, so it hasn't got the context path. And that's taking advantage of parallel deployment, which is designed to have multiple copies of your app, each with a different label. And then new users get the latest one. Users currently using an old version will carry on using an old version until their session expires. But that's parallel deployment, which I don't want to talk about anymore. But what it gives us is this ability to add a label, which is effectively any valid file name you can think of, which lets you get that version or that app name or whatever it is while still deploying it to the root context. So what can go wrong if you do decide to change the app path? Well, broken links is the first one. Redirects. So Tomcat generates the redirect, or the app asks Tomcat to generate the redirect. The redirect will be generated with the context path that Tomcat knows. So it will redirect to /bar if the context is deployed to /bar. Problem is that gets sent back to the client. Client says, oh right, redirect to /bar. Front end server says, no idea what that is. I know what foo is. No idea what this bar nonsense is. No idea, 404, goodbye. And clients aren't very happy. Now you can fix that in configuration, but you get a similar problem with cookies. Cookies have paths attached to them, and the reason they have them is so they're only sent back to the path where they were generated. So Tomcat, when it generates a cookie, will set the cookie path as /bar. Of course, the client knows, well, I'm talking to /foo, so that cookie path doesn't match, so I'm not going to send the cookie. No cookie, no session, app breaks. Just generating links on the fly. If you've got a dynamic page that creates a link that's got the context path in it, Tomcat will create the link with /bar in it. The client needs /foo. Again, it doesn't match. You get broken links. I've also seen some frameworks like Spring MVC with custom headers that involve the context path as well. So lots of places where changing the context path can cause problems. So how do you fix these various problems? Well, don't do it in the first place is the simple solution. But if you really must, and you're using HTTPD and mod proxy, there's something called proxy pass reverse, which will fix the location headers for you. It won't fix all of the HTTP headers, but it will fix the redirects. Cookie path, again, if you don't do it, you don't have to worry about this. But there is an HTTP directive that will help you. Proxy pass reverse cookie path. Now, the thing to note with this, I haven't actually shown an example, but if you use proxy pass reverse, these are in the other order. Proxy pass reverse, it's front end, back end. Cookie, it's back end, front end. So just be very careful with those that you get them the right way round. It is very easy to get them the wrong way round. And then all sorts of hilarity will ensue up until the point where it's 5:30 on a Friday afternoon, it still doesn't work and you want to go home, then it's rather less funny. So yeah, you can do the cookie pass and you can do the redirects. Links, now you're into basically editing the response bodies on the fly, which is not a place you want to be. And you've got lots of options to do it, mod sed, mod substitute, mod proxy HTML, but it's fragile, really fragile. And I've spent with one customer 3 days battling this problem, all because they didn't want to change the context path, and no matter how hard I tried, I couldn't convince them. So we spent 3 days testing their app with breakage after breakage after breakage, and we were on this bit, and actually writing regular expressions to change just the bit you want, particularly when the context path is a fairly common word that appears throughout the text of their app anyway, is tricky. And we were having to write some fairly complex regex to make sure we were basically pulling out the links and nothing else. It was not fun. So it is very fragile and it will create a huge overhead. And if the app changes, you might need to add extra stuff, or some might become redundant, and it's just really hard to track and maintain. For custom headers, again, I'll say it again, don't change the context path. But if you insist on doing it, then you've got mod headers, which will let you edit the headers on the way in and on the way out. I really can't bang on enough about how much pain changing the context path creates. It really is the thing you desperately want to try and avoid when you're reverse proxying, if at all possible. The next thing I want to talk about is security issues. And when you particularly need to be careful is when you're terminating TLS at the reverse proxy, and I'm going to talk about doing it with HTTPD. And the reason for this is Tomcat needs to know whether or not the request was received over a secure channel. And the reason it needs to know this is that there are various rules for good security that Tomcat needs to follow if a request has been received over a secure channel, and mainly they're around sessions and cookies. So a session that's created over a secure channel should never transition to an unsecure channel. You don't want the session ID that gives access to your bank account that you've generated over TLS to suddenly appear in a clear HTTP channel where anybody sniffing the hotel Wi-Fi you happen to be sat at can read that session ID and then connect as you. Cookies are the same. If a cookie is created over HTTPS, then the expectation is that that cookie will only ever be sent over a secure channel. So Tomcat needs to set a flag on the cookie so the browser knows only send this cookie over a secure channel. Now, if you're using mod.jk or mod proxy AJP, they just handle this. Don't need to worry about it. Nice and easy. Everybody's happy. Mod proxy HTTP does not, and that's where you need to be careful. So the first way, as we've already talked about, is using the setting the custom headers on HTTPD and then using the remote IP valve and the SSL valve on Tomcat. Another way of doing it, and the way I actually prefer, is have two connectors on Tomcat. They're both HTTP connectors, but one has the attribute secure set to false, the other has the attribute secure set to true. So on a Tomcat connector, just a brief diversion, on a Tomcat HTTP connector, there are three attributes that you can set independently. Whether it uses HTTP or HTTPS when it generates redirects, whether it's actually secure, so that's whether, am I actually doing SSL on this channel or not? And the third one is, do I think it's secure? And whether it's actually secure and whether I think it's secure don't have to be the same. So you can receive traffic over encrypted traffic and tell Tomcat, no, treat that as unsecure traffic. Equally, you can receive traffic over a clear channel and tell Tomcat, treat it as if it's secure. And where it's really useful is in reverse proxies. Because what you do is you have one connector set up saying, right, I'm the destination for insecure traffic, and another connector set up for secure traffic. And then on your front-end reverse proxy, everything that's received over HTTP, you send to the connector that's set up for insecure traffic. Everything that's received over HTTPS, you send to the connector that's set up for secure traffic. And the thing I like about it is it just separates out all of the configurations. You're keeping the insecure and the secure separate. It just gives you a bit of clarity. Other things that might go wrong if you're doing virtual hosting, so if Tomcat understands different hosts and will respond differently depending on the host, and you're behind a reverse proxy, certainly HTTPD won't send the host information by default. You need to explicitly tell it to do that, so you can do that with proxy preserve host on. And the other thing to bear in mind is client IP-based security. So if your app is performing some security function based on the IP of the client, if you're behind a reverse proxy, the IP it's going to see is the reverse proxies, not the clients. So there are ways of handling that. Again, HTTPD will set the X forwarded header, and in Tomcat you can use the remote IP valve to set that information in Tomcat. So again, Tomcat will think that, okay, that request has actually come from the originating client. So again, you can do things like have security that internal users are allowed to access this, internet users aren't, for example. Again, as with anything else, where you're setting a header in HTTPD that Tomcat is using to make a security decision, make sure you remove anything of the same name that the client sets, otherwise they might be able to bypass your constraints. Okay, so that brings us to load balancing, but it also brings us pretty close to lunchtime. So what I'll do is I'll pause here and see if there are any additional questions. Going once.
Does any of this relate to a version of HTTPD?
Does any of this relate to a version of HTTPD? Everything I've talked about is in, certainly it's all in 2.4 and it's been in 2.2 for years. So mod proxy AJP, you'd have to go back to possibly 2.0, even early versions of 2.0 not to have mod proxy AJP, but certainly it's all in 2.2.
It's with Crystal, it's in your... Yes, it's in 2.2 something.
Yeah, so any remotely recent version will have...
2.0 is not supported anyway.
Yeah, so any remotely recent version of 2.2 will have all of these features there.
Yeah, and I strongly advise to use 2.4.
Of course.
Absolutely. Okay.
How about Nginx? How do you compare HTTPD to Nginx in context of Tomcat?
To be honest, I haven't used it. If you're proxying HTTP, then Tomcat won't care. Tomcat has no preference what's sending the traffic, and all of the things that could act as a reverse proxy, they all have ways of doing the things like adding the information as the headers, manipulating the URL, doing all the sorts of things you need a reverse proxy to do. So, and my personal experience is just with HTTPD, so that's what I tend to talk about, not just because it's an Apache project. I don't talk about traffic server for the same reason. I don't use traffic server, so I don't understand it as well. So anything you can do with HTTPD, I would be amazed if you couldn't do with pick your well-known web server of choice. You can do this with IIS. Even recent versions of IIS have got a lot better at providing this sort of functionality. Historically, not so good, but the more recent ones, it's there as well. And again, one of the advantages of doing it with HTTP is that you open up a wider range of options for things you can put in front of it, because more things tend to talk HTTP than they talk AJP. Nick?
How do you work out what's going on when things start failing and you've got...
Right. The short answer is sometimes with great difficulty when things start going wrong. There are a few things that I have found really useful. One is enable access logging on every node. And one of the things that can be incredibly useful is take the access log from the reverse proxy and the access log from the backend server and look at the two side by side, and you just look for the gaps. The thing to note when you're doing that is log entries are written when the server thinks the request is completed. So if you're dealing with things that have timed out, so for example, you have a long-running request, the front-end proxy has timed it out after 30 seconds, meanwhile the back-end server has processed it and has completed it a couple of minutes later, those entries won't line up. What you might need to do is load them into some sort of log tool and just do basically say, right, take the timestamp will almost certainly be the end time, subtract the request processing time, create a new timestamp, and then order them by that timestamp, then compare, and then you're looking at basically request time, and then they tend to line up a bit better. Unless your web server will actually log the request start time, which is the time it's actually more useful for this thing. The other thing you've got options of doing is you can inject unique request IDs into requests, and then get the front-end server and the back-end server to log them. So again, you can line things up. But most of these sorts of issues, when things have been going wrong, I tend to be able to diagnose just with that. That gets me most of the way there. When it doesn't, depending on what the problem is, I personally tend to go one of two ways. I'll either open up Wireshark and look at the raw network traffic, or I'll put Tomcat under a remote debugger and step through the code. And it depends on what the issue is and what I'm trying to figure out. And again, I tend to go those ways because those are the ways that I'm familiar with. Granted, remote debugging your way through Tomcat isn't necessarily going to be everybody's cup of tea, but occasionally it can be useful. If you are having a problem and you don't think it's the app, by all means, do feel free to open up a bug report. The thing that makes a bug report so much easier for us to reproduce is a test case that demonstrates it. And the more reliable the test case and the easier it is to use, the better. Personally, I'm not a huge fan of Maven projects that I have to download half the internet before I can build the test case, but I will do it if that's what you provide. If that's how you're comfortable producing the test case, we can work with that. I like simple servlets. I've got like a few lines of code that I can just copy, paste, and deploy myself. Or a JSP. JSPs work almost as well. But whatever works, the most important thing is a reliable test case that reproduces it. If you can write one of those, we will find the Tomcat bug. Or we'll find the evidence that demonstrates, actually, no, it's not a Tomcat bug and this is where your test case is broken. But we will still be eternally grateful that you wrote a proper test case for us. We are less grateful when we spend hours and hours wading through a vague bug report only to find that actually it was an app problem in the first place. But we still do that as well. So yeah, if you can reproduce it, but you can't figure out what's going on, send us a test case and we'll take a look. And again, as I said before, we tend to look at them fairly quickly. But if you do need a faster turnaround, then pretty much all of our employers provide services for that at a price. Use it or ask on the users list. I mean, the users list is actually pretty good. You get a reasonable response on the users list most of the time within a reasonable time frame. Okay, it is now definitely lunchtime, so I'm going to pause things there. Thank you for listening for the first half. We'll carry on after lunch.
Thank you.